First of all, we're working more with the standard normal distribution. Alright? Some notation for you. Starts right here. Okay? This notation right here, the N represents we're working with a normal distribution, so that means you can use the 68, 95, 99.7 rule. Okay? Secondly, you'll get the Greek symbol mu. It just represents the mean. The first number here always represents the mean. And then you have the lowercase Greek symbol sigma. Okay? That represents the standard deviation. So if you see that given to you, understand the first number is the mean, the second number is the standard deviation. So here's going to be our first example we're going to do together. Let's say on a particular portion of your SAT test, okay, the mean is 500, the standard deviation is 100, and you score 680. Find your percentile. Find your percentile rank. And what percentile did you score? What's the first thing you're going to want to find? The z-score. Okay? So how do we find our z-score?
Y minus the mean over S, right?
Yep. Your score, take away the mean, divided by the standard deviation. So 680 minus 500 divided by 100. What do you get?
1.8.
1.8. What does that mean?
1.8 standard deviations from the mean.
You scored 1.8 standard deviations above the mean. Okay? What is your percentile? Well, 1.8 standard deviations. I'm going to erase these numbers. These were from yesterday.
What's the letter before 500?
Okay.
199.
Mu.
Oh, add that. M or N. Calm down, everyone.
Mu. It's a Greek symbol. Mu.
It's a combination.
We were just
Okay.
write a regular
Doesn't have this
with a
little-
date next to it.
Little tail on it.
If I wrote it down, would you know what I was talking
Okay.
about?
Practice writing this. Okay? So, your z-score is 1.8. Means you scored 1.8 standard deviations above the mean. What percentile is that? Okay? Well, we don't know. We could approximate. 1.8 would fall about right there. Our percentile rank would be what percentage of the scores are below us. Okay? Two ways you're going to get this answer when the numbers aren't exactly 1 standard deviation, 2 standard deviations, 3 standard deviations. In your textbook, turn to the very back.
There. Grace.
Very, very back, you will see page A, 102, 103. Page A, 102, 103, at the very, very back.
Mine was the 77.
Okay? Your book maybe is different.
I got A.
Mine goes up to 77.
A 74, 75 then.
Thank you.
A 74, 75. I apologize, I forgot I had a teacher position. A 74, 75 for you. Okay? And you'll see a table with a ton of values on it. Okay? Let's look at the second page. Very top left. It'll show you the z-score down the left-hand column, and then the second decimal place across the top. So if we had a z-score of 1.8, or in other words 1.80, I'm going to follow this table down to 1.8, and I just had 1.80. What decimal do you see? 0.9641. What that means is 0.9641, or 96.41% of the area is to the left. See how they have that shaded right up here? Every decimal is showing you what percentage, well, it's not a percentage, it's a decimal. You got to move it 2 spots if you want to write it as a percentage, okay? Or it's showing you basically where you rank percentile-wise, or the amount of area that is left of whatever value, whatever z-score you find, okay? So what if our z-score was 0? What's your percentile rank?
50%.
50, that's obvious, right? If your z-score is 0, you're right in the middle, so 50% will fall to the left of that. Okay? But since we were at a z-score of 1.8, 1.80, we are at the 96th percentile, officially 0.9641, alright? Or 96.41 is our percentile rank. What if our z-score was 0.35? See if you can use this table. What if our z-score was 0.35?
63.68.
6368? Everybody find it?
Yep.
0.35 for a z-score. Is it still a no? Because I want to make sure you can know how to use this table. You good? Okay? Everybody? How about a z-score of negative 2.31? Negative 2.31.
1.04.
0.0104. Okay? Basically meaning you scored right at the first percentile. Okay? Everybody following that? Using this chart? Some people will like to use the chart. Okay? Pretty simple to use. Keep in mind, guys, this tells you what percent or what part of the area falls to the left of that z-score. Okay? So if I reworded the question, what percentage of people scored higher than you? This, very good, Kim. This 1.8 is telling you what percentage of the area or people were below you. So if you want to know the percentage that were above, just take 1 minus 0.96, whatever that might be. Okay? Show you another way if you have a graphing calculator handy. Some of you will prefer this method. You will have that chart available to you on a test. You do not have to memorize that chart, okay? If you would like to use the chart on a test, I will provide the chart for you. Or you can use the calculator, it also will do it for you. Okay, but it's entirely your choice. Okay? Now, again, what percentile rank are we? For a percentile rank question, if my z-score is 1.8, I want to know what percentage of the data falls left. Or what percent rank are we at? So here's what you do. You'll see a VARS key, V-A-R-S. Right above it, it says distribution. Okay? So you got to go second VARS. Okay? Second VARS, and you should see normal PDF, normal CDF, inverse norm, inverse T. Everybody on that screen? Okay? We're going to use the second one, normal CDF. So press enter on normal CDF. Now, you need to tell the calculator you want to know the rough area or percentage of the data from way over here right up until your z-score of 1.8. Okay? Well, we can't just type in negative infinity. The calculator doesn't understand that. Okay? What I'm going to suggest you just type in is negative 99. That would be like saying negative 99 standard deviations to the left. That's going to be way over there, okay? This line will essentially have touched at that point. Okay? So I'm going to type in negative 99. Then comma. So I want to know the area under the curve from negative 99 standard deviations all the way up to 1.8 standard deviations. So 1.8 after the comma. Press enter. And it gives you that 0.9641. Same value, except it's more accurate. The values in your textbook only go to 4 decimal places, right?
Yeah.
Okay. So again, second bars, so you're going to distribution, normal CDF, and then you got to tell it to find the area from where to where. So I chose, because I wanted to know the area from way over here right up until 1.8, I just did negative 99 comma 1.8, and it told me the area that falls from 1.8 to the left. Say you wanted to go from 1.8 to the right. Say you wanted to know what percentage of people scored higher than you. This wouldn't take any math if you want to use your calculator. So if you don't want to use the chart. You could, again, if you want to know what percentage of people scored higher than you, what values could you maybe enter in the normal CDF thing? 1.8 comma 99, sure.
Mine shows negative 1E.
Negative 1E.
Yeah, I didn't even punch anything in. That's just what it popped up.
So you tried. You did 1.8 comma 99, right?
It's supposed to stop like 7.
Or no? Tell me what you're doing.
That's what it says.
Because I went to this.
My phone's almost like 60% of the stuff.
Jack told me it's gonna stop at 7.
This would be a mess though. Like, this is just going to cause to be a mess no matter what.
And work.
This is going to cause to be a mess no matter what. Yeah, I know it's going to be a slap.
Okay. So if I went from 1.8 to positive 99, I found out that about 3.6% of people scored higher than I did. Okay? Let's say you wanted to find a chunk of people that scored somewhere like between two values. Like from negative 1 standard deviations to positive 1.8. You could again use this. You would just type in negative 1 comma positive 1.8 to find the area that falls between those two z-scores. So this is pretty handy if you remember how to use it. Okay? The z-score chart is quite simple as well. Okay? I'm old enough, I did not use this. Alright, I remember using the table. Alright? Questions? Okay, let's do this. Same situation. What percentage of scores, of SAT scores, fall between 450 and 600? What percentage of scores fall between 450 and 600? Go. What are you going to find first? Two z-scores. Go. Do it.
Is it the same mean as before?
Same mean, yep. Same mean, same standard deviation. What do we get getting for z-scores? What's 450?
Minus 5.
Negative 0.5?
Yeah.
Negative 0.5. This is for z-scores.
Next one's 1.
600 was a z-score of 1. Okay? So I just want to know what percentage of scores fall between negative 0.5 and positive 1. The easiest way to do this would definitely be on your calculator. Okay? If you wanted to use the chart, you'd have to take this decimal from the chart and subtract that decimal from the chart to get what's in between. 0.5328. Anybody else? Look at me with questions. Or you got a question?
Yeah, I don't know. Wouldn't you just look at that? Wouldn't you just look at that?
0.5328.
Go from like 0.5, which would be 17.
That's not equal.
Oh.
See how it's not a square, not a rectangle? So that's not exactly going to be 17%. I like the logic, but unfortunately that's a curve there, so it's not right at 17. It's close. I mean, what he said 53 something.
Yeah. 53.
If it was 17, you'd get 51, but it makes sense that it's a little bit more than 17 because that chunk is a little bit higher than that one over there. Other questions? So then you should just type in second vars, normal CDF, negative 0.5, comma 1, and it'll tell you the percentage of scores that fall between negative 0.5 and positive 1 standard deviations. Again, if you're using the Z table, take this decimal and subtract that decimal. Okay? Because this decimal would tell you all of this shaded region. This decimal would tell you all of that shaded region. So if you subtract them, you're left with what you want. Okay? Yes, no? Okay? Alright? Different question. Harvard accepts only top 5%. You need to score in the top 5% to even be considered. What score do you need to get? Okay? Well, we know right here 2.5% falls above 2 standard deviations, so and we did the 1.8 already, and that was that would have fallen in the top 5. But let's figure out exactly what score we need if we want to get in the top 5%. So it's going to be somewhere in here, but we don't know exactly. Okay, what might you be able to do? You could look at the chart and find something that's really close to what?
0.95.
0.95. And if you look at the chart looking for 0.95. Looks like about 1.5.
1.65 or 1.65.
It's right in between 1.65 and
1.645.
yeah.
1.645.
That would logically be a good guess since this only goes to 2 decimal places. 1.645 is about where 90% of the data falls, or excuse me, 95% of the data falls below you. Okay. So what you could do then is you could use your z-score formula. You know what z-score you need now, right?
1.645.
1.645. You don't know what your score is. You know what the mean is. You know what the standard deviation is. Could you figure out your score that way?
Yeah.
That would work. Calculator. Make sure I get this right. I'm going to go to second vars again. I'm going to do inverse norm. And type in 0.95. Inverse norm, 0.95. So that is going to be more accurate than our guesstimate of 1.645, because we guessed 1.645 because it was right in between 1.64 and 1.65, but it's not a linear function. This will actually tell you exactly how many standard deviations you need to be at, or at least exactly to a lot more decimal places. Okay? So if you do inverse norm 0.95, tells you then that you need to score 1.644853626 standard deviations above the mean. So then I could use that decimal instead. Take it times 100, add 500. What score would we need to get to be considered? Well, if I knew this was this number, and I'm solving here, I multiplied by 100, and then added 500. Okay? So according to that, I need a score of 664.48. I don't know SATs, but I'm guessing they don't come as decimals, your score? Anybody taking the SAT? Not in here? I don't think they do decimal scores either. So in that case, then if I was truly answering the question and wanted to be in the top 5%, would 664 be enough?
Yeah.
You need 664.485, so 664 is not high enough. You better get a 665 if you want to be in the top 5%.
Which I did.
Okay? All right? So, you'll work a lot with the table or your calculator trying to answer these questions. Sometimes it's a good idea to try and draw a picture. Harvard accepts only the top 5%. So in other words, you want to know when that is 5% right there. Okay, there's kind of a picture that goes with that problem. So it gives you a little better idea of what you're trying to find. Okay? I think it's helpful to draw a picture. They'll probably ask you to draw some pictures to represent each type of problem. Okay? Homework is on the calendar. You can stop recording.